In this video, I want to go through some more advanced examples of the chain rule, and so all we need to do is see more of this stuff and get more practice with it. So here we go. So my first example: given that g of x is the sine cubed of x, find g prime of x. This is probably one of the most important examples that I'll go through. This is something that we see show up a lot, and we really need to be able to deal with it. What's important is it's important that we know what this thing means. When you have a trig function being raised to a power, and this is personally, this is what I do every time. I'm not even taking the derivative yet, I'm just rewriting this. When someone says sine cubed x, that is shorthand for this. It means that they want you to do the sine of x and then cube it. It doesn't mean, this is actually nonsense, it doesn't mean sine x. That's silly. That actually doesn't mean anything, right? What it means is, it means that we are going to do the sine of x and then cube that thing. So now that we know the chain rule, this should make more sense. We need to be able to look at this and think about this as, so in the context of this problem, what is the outer function and what's being composed within that? So pause the video and think about that for 10 seconds if you haven't figured it out already. What's the outer function, what's being composed within it? Well, my thought here is that the outer function is the something cubed function, the x cubed function, and what's being composed within it is sine x. Right? So how are we going to do this derivative? Well, we begin by taking the derivative of the outer function. So how do we do the derivative of x cubed? Well, we're supposed to do 3x squared. But the difference is that my x, my inner composed function, is sine x. So the chain rule tells us to leave that alone, leave that composed within, but then multiply by the derivative of that thing that was composed within, which is cosine x. So this brings us to g prime of x being 3 sine squared x cosine x. And like I said, this business right here of trig functions being raised to a power is one of the most common examples of the chain rule. So it's really something you guys should know. Make sure you got it down. Do not be surprised if that shows up on the quiz this week. So this next example. Given h of x equals 4 over 3 sine x minus 2, find h prime of x. When we first learned derivatives, I tried to make a lot of noise about, a lot of times you need to change a problem, you need to move it around, you need to manipulate it so that you can see what's happening. Before you try and take a derivative, you need to be able to see what's happening here. It may be hard for you to see what the outer function is here. What function is going on here? The way that I would rewrite this one is I would rewrite this, and notice I'm writing h of x. I'm not writing h prime of x because I'm not taking the derivative yet. I see this problem as being 4 times that entire thing in the denominator, 3 sine x minus 2, all of that to the negative 1 power. When I write it that way, I feel like it becomes so much more clear what the outer function is. So, pause the video for a minute, think, what is the outer function here? What's being composed within it? Well, the outer function is the 4x to the negative 1 function. That's a power function, right? If this was 4, x to the negative 1, that's what it would be. And what's being composed within it is this 3 sine x minus 2, right? So that's the framework that we have as we're working through taking this derivative. When I do h prime of x, well, the derivative of something raised to the negative 1 power, we bring that negative 1 power down, negative 4, we leave the inside alone and we subtract 1 from the power. Right? That's how we do the derivative of something raised to the negative 1 power. Now the chain rule tells us to leave the inside as is. The function that's composed within stays the same, and we multiply by the derivative of that function that was composed within. That derivative of the thing that was inside is 3 cosine x, minus 0, but we don't need to put that. Now that I have this thing, I can go back and pretty it up. We'll have h prime of x is prime, there we go. Let's see here, in the numerator we've got negative 12 cosine x, and in the denominator we have 3 sine x minus 2 squared. And there it is. There's our derivative, right? Again, I really feel like we would have made a huge mess of this thing if we hadn't stopped to think about how I can write it as a composition of functions that we know and that we can work with. Now this last example is one that we really haven't seen before. On the one hand, it is something we've seen before. This is a trig function raised to a power. So we sort of know that's going on. In fact, I hope you guys recognize that the first step you would have taken here is to say, hey, I know what this means. This means the cosecant of 5x all squared. Right? And I don't want to sort of give away the secret of what this is, but pause the video for a minute and see if you can recognize what it is about this function that makes it different and special and worthy of consideration. So the issue with this one is, like, what is the outer function? Like, if we try and compose this thing, your outer function is something squared, right? And what's being composed within that? Well, what's being composed within that is cosecant of 5x. And what's weird is that cosecant of 5x, even that's going to take the chain rule. That thing is the cosecant function with 5x composed inside of it. So this is effectively a double chain rule problem. We're going to need to do the chain rule twice to get through this problem. Right? So when I set out to do f prime of x, we start with the outermost function. The outermost function, I wrote it over here, was the x squared function. So the derivative of x squared, or something squared, is supposed to be 2 times that thing raised to the first power. Right? Now what's the thing that's sitting inside? Well, the thing sitting inside is the cosecant of 5x, and all of that gets left alone. Now the chain rule tells us to multiply by the derivative of what was inside. Right? So this function was inside. What's the derivative of the cosecant of 5x going to be? Well, that takes the chain rule, so we work with the outside of that thing, cosecant. What's the derivative of cosecant? Well, the derivative of cosecant is negative cosecant times cotangent. Sorry, I'm having to wrap this problem a little bit. And what goes inside of those cosecant and cotangent? Well, it's the thing that's composed within that. There's a 5x here, and there's a 5x here. And the chain rule tells me to multiply by the derivative of that thing inside that I left alone, which is 5. Okay? So you've got this long chain of stuff, and it's sort of, interrupted by this thing over here. Now I'm going to go back and try and pretty this up a little bit. The least that I can do is I can grab these constants, the 2, the negative, and the 5, and pull them to the front. I can end up with negative 10 out front. Then, it's actually interesting, this is all just the first power. I have a cosecant 5x and another cosecant 5x. So I have cosecant squared 5x times the cotangent of 5x. Okay? And there it is, that's my derivative. Now, I'm not going to lie, the chain rule, and especially, multiple chain rules or mixing chain rules with product rules, this is where stuff starts to get complicated. So if you're not seeing these things, if you're not getting them as you're practicing them, make some noise. Talk to me about it. Talk to the people in your group about it. We need to make sure we get through these things. The chain rule, the product rule, and the quotient rule are everywhere in the rest of this class. So it's really, really important that we get these things down now.